Hello guys, welcome back to my channel once again. Today we'll learn about some of the chemistry concepts in daily life. Okay, let's discuss about the chemistry. हिंदी में इसको रसायन बोलते हैं और हिंदी में लोग पहले कैसे सोचते थे रसायन विज्ञान के बारे में. लेट्स डिस्कस दैट. सो हमारे हिंदू रिलीजन में और सो से इस पद्धति में they used to think that every matter has five properties. Either पृथ्वी का तत्व होगा उसमें which is solid, जल तत्व होगा which is liquid, and आकाश तत्व होगा which is nothing but space, अग्नि तत्व which is nothing but warm air. Okay, I think पृथ्वी, जल, अग्नि, आकाश, एक और होती है आई थिंक वायु. वायु इज़ नथिंग बट एयर. अग्नि को आप वार्म एयर ना कह के इफ़ यू कुड से इग्नाइटेड स्टेट ऑफ प्लाज्मा. स्टेट ऑफ प्लाज्मा. ओके, सो वो कुछ भी देखते थे तो उसमें वो अगर लेट्स से उनको कैल्शियम कार्बोनेट का कुछ टुकड़ा मिला तो दिल से कि ये पृथ्वी तत्व है क्योंकि ये पृथ्वी जैसा है. और एंड देन दिल से कि जो पृथ्वी का व्यवहार है वो स्थिरता का है, राइट, इनर्शिया का है, न्यूटन के लॉ को फॉलो करेगी. एंड इफ़ मिक्सड विथ वाटर तो वो कुछ गैसेस रिलीज करेगी एंड देन एक सोल्यूबल और अनसोल्यूबल कंपोनेंट बनाएंगे. फॉर एग्ज़ाम्पल आपने सुना होगा कि हमारे यहाँ चूना लोग खाते हैं प्रसव में, सो दैट क्योंकि उस समय कैल्शियम की कमी होती है. एंड पीपल बैक देन नो दैट कि हमारी हड्डियों में वो चूने की तासीर है बिकॉज दैट इज़ बाइंडिंग, दैट हैव बाइंडिंग नेचर. और चूने की भी बाइंडिंग नेचर होती थी. पहले लोग जितनी भी कंस्ट्रक्शन के काम करते थे चूने से करते थे rather than cement. So by these or thinking that macro thinking led them to develop the Rasayan Vigyan. But we'll not discuss that in detail, but I wanted to let you know that the chemistry is actually very interesting if you see it from a philosophical perspective and apply the deductive reasoning, right, that you saw somewhere, deductive and inductive reasoning, that you saw some properties of some matter and you apply it as a global parameter and makes the rule, and that becomes the chemistry. For example, let's take some of the problems and we'll discuss how today we can apply the modern chemistry to solve some of the problems. We know that in water body, if water lives are residing, they need oxygen. So oxygen is dissolved in water. Now any gas can dissolve into any liquid. How to know that how much oxygen is there? Let's say if oxygen is less here, maybe fish can't survive, she'll die. So how to find out what is the amount that it is holding? So for that we have the Henry's law, right, where the concentration of air, gas, so to say, in liquid depends on the pressure, the partial pressure it is applying on that, right, with the Reynolds law that gases generally don't act as an inert with the liquid. In that case you can apply Dalton's partial pressure law, and the partial pressure law depends the fraction of the mole of the gas. So that way here it is Henry's constant and we write partial mole fraction, and partial mole fraction becomes the volume fraction, and volume fraction can be replaced by partial pressure. So at NTP, normal temperature and pressure, if we see the gas in the atmosphere, 21% is oxygen. So that means its molar component is 0.21, and that will become, so 1 atm pressure if gas has, atmosphere has, the O2 will have 0.21 atm. So that much pressure is applied here, and that will determine how much O2's level will be in the liquid, in water. So now it could be 0.21. CH we have to find through experiment, and we have the data at 25 degrees centigrade. It has 2.45 into 10 to the power minus 4 mole per liter. So we can put it here, and we can find that roughly it will come as 8 mg per liter. So in 1 liter of water, 8 gram of oxygen can be stored. So if gas has a volume of, let's say, 10 meter by 10 meter by 3 meter, then in 300 meter cubic could be converted into liter. That will come around, I think, 300 liter if we approximate, and that means it has 2400 gram, which is nothing but 2.4 kg of oxygen it stores. So water go through, river flows through at NTP. So this much of oxygen is already being dissolved through air, through carrying air. And if it is falls down, let's say if it is coming through Himalaya and it is coming through a fall, then there the atmospheric pressure, as we go up, the O2 level there would not be that much. So that's why you see the fish or any water lives reside in the lower water bodies more compared to the higher one. Also in colder air, because as depth increases, sunlight doesn't reach, so temperature of air would be lesser. So more water lives can reside here, because as water get warms, the gases dissolved will move faster and it goes outside, right? So let's discuss about something else, like we cook something, right? When we cook, what we do, let's say we have lentils. So we know as human body, we need energy, lot of energy and metabolic reaction through enzymes to digest the food, right? To digest, and how it digests, it converts all things into glucose, all carbs into glucose, and all proteins into amino acid. So it costs a lot of energy. So when we digest the food, it's complex carbohydrates, carbs, it breaks down to more simpler, like C6, H12, O6, and then some N. This N will become lesser than 10, like it will be more simpler form, and whatever it's saturated bond like triple bonds and single bonds, these will break down and it will become in singular bonds. So it will be easy to digest. So our body doesn't need to do a lot of work to convert it into glucose or amino acids. Okay, so how does cooking do that? Let's take an example. It requires a lot of pressure and temperature, right? And a medium, let's say in cooking we do take water or mostly oil in vegetables, right? Because they are harmful and these can be eaten, and also oil is a good conductor of temperature, right? So and also how we cook, the cooking methodology, how we got here, it was evolved through generations. लाइक इन हिंदी हम सौंफ डालते हैं, जीरा डालते हैं और बहुत सारे मसाले डालते हैं, और वो मसाले वॉज टू कैंसिल आउट ईच वंस इफ़ेक्ट, क्योंकि खानों में ग्लूकोज होता है ना, तो उसमें थोड़ा चटपटापन लाने के लिए नमक डालते हैं, एंड देन मिर्च डालते हैं, एंड देन उसकी गर्म तासीर को रोकने के लिए सौंफ डालते हैं दोपहर के भोजन में, एंड लॉट ऑफ अदर थिंग्स, एंड दीज आर प्रिंसिपल, नथिंग बट दोज प्रिंसिपल वी डिस्कस्ड अर्लियर। वहाँ से आता है कि उनकी मैक्रो प्रॉपर्टीज़ क्या हैं, एंड उससे रिलेटेड हम औषधि बोलते थे इवन आयुर्वेदा में, एंड उसको उस तरह से उपयोग में लाते थे। खैर, लेट्स टेक एन एग्जाम्पल. For example, so इसमें we'll learn about chemical kinetics using this principle. So what happens if we increase the temperature or pressure, the reactions rate increase, that is K. So we have one formula, RNS formula, that rate of reaction depends on activation energy and the temperature. So it's inverse to inverse, that means direct. So K is kind of proportional to T. So if we increase the temperature, the rate of reaction would increase. So let's say if we are making one lentil or boiling something or even steaming the idli, for example, in open tab with using water. So in open scenario, at 100 degrees centigrade, this will get on boiling. The temperature will rise to 100 and the lentils will boil at 100 degree. But if we use cooker kind of setup where this is not open at all, then that 100 degree, since pressure will increase and that will cause temperatures to increase. So that same cooking will come as 120 degrees centigrade. Okay. So now if we have to find out if this condition takes 30 minutes to cook the lentil, this setup, how much time it will take. So to solve that problem, we'll use Arrhenius equation because it relates the rate of reaction to the temperature. So if we simplify this equation, this will become log K2 upon K1 if we take the two condition, and it will become EA upon R and 1 upon T2 minus 1 upon T1. I'm taking the negative sign into inside, so that way we reversed it. Now if we put the values, activation energy we assume 50 joule per mole, and then okay, and R is 8.3 in SI unit. This temperature will go 120 plus 273, which will become 393, minus this would be 373, and if we solve for it, this will come as an ln K2 upon K1. It will come around 0.82. I have solved it using calculator. So now K2 would be e की power 0.82 upon K1, right? Now e की power 0.82 is nothing but 2.27. So and K2 and we know if the order of reaction is the first order, then T2 and T1 could be proportional to the rate of K1, and we know this T1 scenario takes how many minutes? 30 minutes, right? So and then the constant is let's say K2 is constant at 2.27. So K2 will take, sorry, I've used oh, I'm so sorry, this time would be inversely proportional, since more time less rate of reaction, right? So this will 1 by 2 and this will become 30 upon 2.27. That means the second scenario, this one, this will roughly will come around 12. So this will take 12 minutes, like 2.27 minutes times lesser time than this scenario. So that's why pressure cooker have less time to cook lentils. Okay, so yes, that's it. Thank you for watching the video. Comment me if you want any topic to be discussed. We'll discuss. Thank you so much.